Common mistakes. Emily makes cakes, and she's just gone through the whole store and marked everything as 50% off. Her boss comes in and says, "This is actually a mistake. What you now need to do is increase everything by 50%. But does decreasing and then increasing by the same percentage get you in the same place? The answer is no. Why might that be? Let's have a look at one particular example. Emily discounts a $40 cake by 50%, but her boss tells her that it is a mistake and she needs to increase it by 50%. So to decrease by 50%, we multiply by 0.5. So we end up with $20. Now, if we increase by 50%, that would be the same as multiplying by 1.5. That gives us an answer of $30. Therefore, we don't actually end up at the same price. Emily's boss insists that it can't be correct because it just doesn't feel right. And this sometimes happens in mathematics, but there is a good explanation. If you halved a cake, to get back to the original size you would require 2 halves, which is double the amount. To double something is not a 50% increase, it is in fact a 100% increase. So how do we actually do it? Well, we need to go back to some formulas. So we have seen the top formula in a previous video, that the new price is equal to the original price times R. If we rearrange this, we can get the original price is equal to the new price divided by R. So let's have another go at example 1. We got the new price is equal to the original price times R, which gives us $20. So we had that right in our earlier example. But to get back to the original price, we take the new price divided by R. 20 divided by 0.5 gives us $40. So now we've ended up back at the same price. So we know that this is the correct method. Extension time. You go to your favorite game store again, and this time the shop assistant gives a very convoluted explanation of the pricing structure. He says for the past week he's been rolling a 12-sided dice, and on alternate days he's been increasing the price or decreasing the price. This table shows what happened for the week. On Monday there was a 7% decrease, on Tuesday there was an 8% increase, on Wednesday there was a 6% decrease, on Thursday there was a 12% increase, on Friday there was a 4% decrease. As a hint, I've already calculated the R values on the right hand column. So what was the percentage price decrease or increase? So here is that table again. Pause the video now and have a go at the problem by yourself. In previous videos, I've emphasized the importance of the R value, and for working out successive discounts, it makes the problem much easier. For instance, what we need to do here is, whatever the price is, keep multiplying by the R value each day. The result is 1.015, or a 1.5% increase. This problem can be done other ways, but this is the quickest way of doing it. The shop assistant is proud of himself. He's used the dice to randomly increase the price by 1.5%. So he comes up with an alternative strategy. This time he's not going to use the dice, he's going to increase or decrease the price on alternate days by 10%. But you know that this is a bit of a dumb idea. To alternate between 10% discounts and increases, you multiply 1.1 by 0.9 and then keep on alternating. Or, if you want to shortcut it, you can put in brackets 1.1 times 0.9 and take it to the power of anything you would like. I took it to the power of 100 to see what would happen after 100 iterations. And you'll notice that I got a value of 0.37. And in fact, if you keep putting in a higher and higher value, you would eventually end up at 0. This means that the shop assistant would eventually have his prices all set at 0, which makes it a bit of a silly pricing mechanism. To recap, adding 50% to an item doesn't reverse a 50% decline. Also, when we alternate between the same percentage, eventually it reduces the amount towards 0. Thanks for watching. Please subscribe and hit the like button. Please leave a review and a comment. I'm not a financial advisor. I'm an experienced maths teacher with a passion for teaching students financial literacy. Please read the disclaimer.